Bless you. So there's our schedule for the rest of the semester. Okay.
So the 414, that's like what we did a couple weeks ago.
Yeah, where you just come to class and I'm here to help. Yep. Okay. Help get you caught up if you're stuck on anything or anything like that.
For our final, is it gonna be optional or like depending on what your grade is in class?
Yeah, it is optional, but it does depend on like if you got an A, then you wouldn't want to, you don't have to mess with it. But or if you're happy with your grade, you don't have to mess with it. But if you want to try to improve it, you're welcome to take it then. Okay. So the final exam, even though it is optional, it cannot hurt your grade. Okay. So like if you're borderline on a grade or something and you want to come try it, that's fine. It won't make your grade go down, okay, but it can make your grade go up if you do better. Okay. So all I'm doing with the final exam is if you make higher on the final than you did on one of the other 3 tests, I'll use your final exam score instead of that lower test grade. So, all right, so test next Thursday. It'll be test 3. And also, if you know you're not going to take the final, then on this last Tuesday of class, there's nothing for you to do. Okay. Questions on anything from the schedule? Good with all that? Okay, so we've got one last section. To do. 4. And this section, we're looking at some properties, some way we can manipulate logarithm expressions. And then we'll look at one thing that can help you figure out logarithms in your calculator. So, right at the beginning, we've got 3 properties to write down. What we're calling the laws of logarithms. Okay. So number 1 is if we've got some logarithm, I've got log base b written on there, so it applies to any logarithm, and no matter what the base is, even applies to natural logarithm when we write it that way with base e. And so it applies in any situation. If we have the logarithm of a product, so logarithm of x times y. Then we would say we can expand this thing, and we can split it up. And that thing is the same thing as if we write log base b of x plus log base b of y. Okay. So it works both directions. Okay. Going from left to right, if we have a product inside of our logarithm, we can split that up into separate logarithms by putting a plus sign in between each one. Okay. Or if we have 2 logarithms with the same base and we're adding those together, going from right to left, we can write that as one logarithm and we multiply the arguments together, right? The x and the y get multiplied. Okay. So if we're just trying to evaluate a logarithm, sometimes that's helpful. Or if we're trying to solve an equation that has a logarithm in it, then that can be helpful. Okay. Number 2, similar idea. except we're thinking about having a fraction or a quotient inside of a logarithm. It's almost the same, but when we had multiplication inside, it turned into addition of two logarithms. When we have division inside, or a quotient or a fraction, however you want to think about that, it turns into subtraction. So that would be log base b of x minus log base b of y. And then one more. Property number 3, if we're just dealing with one logarithm. If we have log base b of x to some power, n power, so I got written there, then we can rewrite that the n can come out front. That's n times the log of just x. So that one's saying if we have an exponent inside of a logarithm, we can move that out front and multiply the logarithm by that exponent. So there are our 3 big properties for this section. Pretty much everything we're going to do just revolves around applying these 3 things. And then we do have one other formula that we use with a calculator. It's not a big deal. Alright, so 3 properties. Really, we kind of have 6 things to keep in mind because you can use them both directions. You can go from the left side to the right side, or the right side to the left side. Okay. Alright, so let's look at how these things get used. So going one direction, we'll have some problems where it'll say expand the logarithm expression. So it'll start off giving us kind of a complicated logarithm, and then we're going to split it up into pieces using those 3 properties. And, so here's one that's not too bad to start with. I'll give this log base 3 of 7x. Don't have too much going on this one, so there's not a lot we can do to expand it. But one thing we can do, so remember 7x means 7 times x. So since we've got a product in here, we can turn that into addition with logarithms. So this log base 3 of 7x gets split it into 2 logarithms. That would be log base 3 of 7. And since it was multiplication, it turns into plus log base 3 of x. Okay. That's all we can do on that one. It didn't have a lot going on. Okay, so it's just using property number 1. Okay. Let's see. Let's do another one. Okay. It's okay if you have more than one term. Like on the inside of this one, we've got 7xy, so we've got 3 things multiplied together. When you split it up, you can split it up just 2 at a time. Say like I'm going to split this piece off and then split this piece off. If you want to do it that way, or you can do it all at once and you expand. So this thing, we've got 3 terms on the inside. So if we use property number 1, we can end up with 3 logarithms. And that would be log base 5 of 7 plus log base 5 of x plus log base 5 of y. And because they're all multiplied together inside the log, so each one we can write in its own logarithm, and since it's multiplication, it's all addition. Usually on these, what the goal is, when it says expanded as much as possible, usually we only want one term inside each logarithm. That's what we're after on those. So that way you kind of know where you're headed. Okay. Let's look at this one. This one's a little more complicated. Got multiple properties on this one I can use. There's that one. We want to expand this thing as much as possible. This is about as complicated as they get for us. We're not going to get too crazy with it. Okay. So we've got 3 things inside of our logarithm. We've got a 5, and then we've got an x squared, and then we've got a y to the third, y cubed. Okay. So we should hope we end up with like 3 logarithms after we split this thing up. One thing to mention that might cut down on mistakes is if you're dealing with division, if you've got a fraction involved, do that in one step on its own. If you're trying to split this up into 3 pieces all at once, it can be a little tricky to make sure you don't get a sign error in there, because division gives us a minus sign, so we have to be a little careful when we're dealing with division. So what I would do first on this one is I would split the fraction part up. So if we've got a fraction, then we can write that as 2 logarithms with subtraction. So that would be log base 2 of the top, 5x squared, minus, because of the fraction, log base 2 of the bottom, which is y to the third. So that would be my first step. And then we've still got some expanding we can do. Like our first logarithm still got 2 terms. It's got a 5 and an x squared. And then we've also got a property where we can get rid of these exponents. So we need to keep going. So I'm going to split the log of 5x squared up next. Right? That's 5 times x squared. So you can split it into 2 logs with a plus sign in the middle. So that'd be log base 2 of 5 plus log base 2 of x squared, and then we already had minus log base 2 of y to the third. And then the only other thing we can really do is use that third property where we take the exponents inside the logarithm and move it out front. And we've got 2 places we can do that. So nothing we can do on the first part here. It's just log base 2 of 5. But then we can take the 2, that's the exponent, move it out front. So take this and move it down out front. And then we're also going to take the 3 and move it in front of the other one. So we'll get plus 2 log base 2 of x minus 3 log base 2 of y. we're out of properties. We don't have anything else we can use on that one. So. Questions on what the heck we're doing? Got it again. I'm just using those 3 properties. Okay. And then sometimes they'll give us a problem really where we're just doing the reverse. Like it'll start us off with something like we ended up with here and tell us to combine all of these things so we can work backward. So it'll say something like, what does it say? So like combine the expression, and what that means is it means combine the expression, and we know we're done when we only have one log. Okay, so let's see. I didn't give you as many of these. So maybe something like that one. Okay. So the first thing to look for is to see if we've got any coefficients in front of the logarithms. So we need to get rid of those first. Okay. So on the second one, we've got a 2 in front of log 3 of x. So we can use like the reverse of property 3 and take that 2, move it up into the exponent inside our logarithm. So that would leave us with log base 3 of 5 minus, I've moved the 2, the log base 3 of x squared. Move it up there. Okay. And the only other thing we've got to deal with is we've got 2 logs, and in between them we've got a minus sign. So that means when we put them together, it's going to turn into division or a fraction. And so the thing inside the first logarithm goes on the top, so it'd be log base 3 of 5 over x squared. Okay. Now everything's all inside of one logarithm, so we're good there. Another way about thinking about that one, as long as you're using the properties, there's more than one way to go about these. So you could have taken a negative 2 and moved it up as the exponent. If we do that, we'd have log base 3 of 5 plus, because we got the negative, we took it away, log base 3 of x to the negative 2. And then when we combine these 2 logs, we would multiply because it's plus now. And that's correct also, it just has a negative exponent. So if we wanted to get rid of the negative exponent, we would take and move it to the bottom. We get the same thing we got here. I think WebAssign doesn't mention that you can't have negative exponents, so I think it'll take either one of those. Okay. Questions on the properties? One other thing I need to show you. So this one, that was combined, right? Let me do another expand here. Forgot to mention one situation that can be a little confusing, so something like that with a square root. Square root we could rewrite as a 1/2 power. So a couple ways you could think about writing it. You could think about x to the 9th to the 1/2. It's a little messy to write it that way, but really nothing wrong with it. Then the 1/2 we could bring out front. So that would be 1/2 log of x to the 9th. The 9 we could bring out front. So there we would end up with 1/2 times 9 log of x. If we multiply the 1/2 and the 9 together, that's 9/2. You can do that all in one step. If you remember what to do with the 9 here, or you get here and you remember the rule, if you have an exponent raised to a power, you multiply, you get the 9/2 power, and you can just bring the 9/2 out front from there. You kind of get to skip a couple of steps. It's going to be 1/2, yeah. Yeah, so just a refresher here, square root, so we'll do square root of x, is x to the 1/2. If you have a cube root, x to the 1/3. And in general, if you have like the nth root of x to some power, whatever powers with the x goes in the top, whatever powers or whatever number is the index on the radical goes on the bottom. So like this, our index is 2 on the bottom, that one's 3 goes on the bottom. So using that, we could have said, okay, I'm gonna have 9 on the top and 2 on the bottom, and jump the next step. We could have jumped at 9/2, so bring it up front. Okay. Other questions on those? Okay, so let's kind of combine this stuff with a little bit of what we talked about last time. There'll be a few problems in the assignment that say use the laws of logarithms. So use these properties we just talked about to evaluate the expression. So if you see evaluate, that's going to mean we're not going to have a log in our answer. We're going to have a number. So think about one of those. What about that one? We got log base 6 of 6 squared. We use our laws of logarithms. The only thing we really got going on we can use, hang on, sorry, well, the only thing we really got that we can use is that we can bring the exponent up front. This will be 2 times log base 6 of 6. Then we're trying to figure out a number for our answer. Anybody remember what log base 6 of 6 would be? It'd be 1, yeah. So anytime, here's a refresher. Anytime we've got log base b of b for the base and the thing inside match, that's 1. Okay. This thing just turns into 2 times 1, which is 2. In that particular situation, that's technically what we're doing. We're bringing the exponent out front, and then we have 1, so 2 times 1 gave us 2. That one kind of comes up pretty often where you got the base matching the thing on the inside, but it's got an exponent. So this one kind of gets shortcutted sometimes, and we'll just say, okay, well, the base matches the argument, so it leaves us with the exponent. Okay, that's fine, too. Let's do another one. Sometimes these are not real easy to see what to do. All right, those logarithms are a common logarithm, right, where we don't write the base. You remember what the base is on those? 10, yeah. If it doesn't have a base written, it's base 10. And so looking at the base will give you a good hint on what we're trying to end up with, because usually on these, when we're going to come up with a number as our answer, we want to end up with a situation like this where our base matches what's inside, or where our base matches some power of what's inside. Okay. So on this one, it's base 10. So a pretty good guess we want to end up with log of 10 to some power. Okay. Just using our laws of logarithms, we've got 2 logs with a plus sign in between them, so we can combine those by multiplying, so that'll be a log of 500 times 200. Okay. If we multiply that out, I get log of 100,000. The shortcut there is we've got to have 4 zeros, and then 2 times 5 is 10. So there's my 4 zeros, and then the 10 in front. You can use a calculator too. So then we said our base is 10. So to get things to cancel out, we want to rewrite 100,000 as the power of 10. So there's a little trick to that too. To know what power of 10 that is, we just count the zeros. Okay? So we got 1, 2, 3, 4, 5 zeros. So 100,000 is 10 to the 5th power. Okay. And then we said our base is really 10 there, so you can do the thing about moving the 5 out front, and then it's 5 times 1, or you can just realize it's going to be 5. Okay, let's do one more. Do one more. Here's this one. The same thing, we want to end up with a number as our answer without a logarithm. Our base is 5. So that kind of gives us a hint. We want to be thinking about powers of 5. I'm just using our logarithm laws. We can use number 3 and bring that coefficient out front inside. So 125 to the 1/3 power. You could punch that in a calculator, or 1/3 power is the same thing as cube root. Punched it in that way. Cube root says what times what times what. Okay, what times itself 3 times gives us 125. Or if you just punch in the cube root of 125, that is 5. 5 times 5 is 25. 5 quarters is $1.25. So. And what's our final answer on that one going to be? 1. Because the base and the argument match. So. Okay. Any questions on that one? Yeah. Okay, so one last thing to talk about. And it's using a calculator, so it's not bad. Okay. Got this thing called the change of base formula. So if you have logarithms written in one base, you can use this to rewrite them into another base, or one thing this gets used for is if you have logarithms with some weird base, like you got base 3 or something like that. A lot of calculators, some of them will, but a lot of calculators will only do the common log, base 10, and the natural log, base e. And then, so a lot of calculators, if you have something like log base 3 of something, you can't calculate that. Some of them you can. Some of them will do it, but it's a little hard to find where to do it. Okay. So to do this change of base, and it's pretty easy. So the idea is that if we have some weird base logarithm, we can change the base, and then we get to pick what our new base is going to be. So we can use base 10 or base e. That way we can do it easy in the calculator. So change of base formula says if we've got a log with some base of something, okay, then that is the same thing as taking, I'm going to do the common logarithm first. So that's the same thing as taking the common log of a and dividing that by the common log of the base, b. That would be one way we could do it in the calculator. So that uses common log. You can do it with any base. Okay, so we could change this to any base we wanted to. We would just use log base whatever on the top and the bottom. Okay, so the other really useful one would be to write natural log of a over natural log of b. But you could use any base. So it's the log of whatever's inside the logarithm over the log of the base. And then it changes it to our new base. Okay. So the way that's useful is if we have something like let's see, log base 6 of 9. Our calculator might not do base 6 logarithms. A lot of them don't. So we could either use the natural log or the common log to figure that out in our calculator. So if we did natural log, that'd be ln of 9 over ln of 6. And we could punch that in our calculator, so let's see. I think WebAssign makes you go out to 6 decimal places on these, so something like that. All I'm punching in is natural log of 9 divided by natural log of 6. And then get that. And that's the same thing you'll get if you do have something that will do base 6 logarithms. And you get the exact same thing. Or we could have used the common log. Let's do another one. I did like log base 5 of 7. So if we wanted to do the common log, base 10 log, we could do log of 7 over log of 5, and then we can punch that in the calculator. So here I get like 1.209 0.62, something like that. So instead of having to deal with some weird base, you can do change of base and then figure it out. We won't get into it, but also if you have an equation that has like logarithms with 2 different bases, then you can change one of them using the change of base formula, and that way you can combine the stuff like you need to. And because our properties, way back at the beginning, our properties only work if all the logarithms involved have the same base. Well, these 2. That could be useful. All right, so it's not a lot to remember, okay? But because some people's calculator will do these and some people's won't, on the test, I'll say use the change of base formula and give you something like this, and I need to see you write it like this, and then you can give me the decimal. So it's just the log of the thing inside over the log of the base. It's not hard to remember. Okay? So it should be an easy problem. All right, that's the end of stuff. So, end of material there. Here's the schedule if anybody missed it and want to get it written down there. You need me? Get one? 1 second.